Hello test takers, welcome back to Exam Prep Solutions, and today we have another sample problem here. This one is from the mathematics section. We're going to be covering some integral functions here. We have a free guide called the 5 Steps to Solving Any FE Exam Problem. You can download that guide for 100% free. It's in the description box. Just tell us where to send it and we'll send that one to you. Okay, let's dive into this problem here. So the problem statement is calculate the area under the curve of the following function between 5 and 10. And so whenever you get a problem where it's stating area under the curve, that's essentially code if we translate that to taking an integral. And in this case, more specifically, a definite integral. So we're going to be taking an integral here. Now, technically, you could come over and you can try and count based on the y-intercept. This is the amount of area, and then estimate and try to find out. But it's going to be much more exact if we take a definite integral, and actually probably not that hard. So we just need to know how to set up the equation properly. I've got the FE exam excerpt over here showing the equation for a numerical integration. So the equation of this line is 3x plus 4, and we're going to be taking a definite integral of this equation. And we have to remember that our bounds are going to be between 5 and 10 because that's the area it wants to know. So essentially what we're going to be doing is we're going to be integrating and calculating the area under the entire curve up to 10, and this essentially subtracting this area between 0 and 5, and that will give the area that we want, essentially. So it's not between 0 and 10, it's between 5 and 10, and we just need to set up our definite integral properly in order to achieve that. So for 3x plus 4, if we remember integration, we add 1 to the power and then divide that by the new power for this specific equation. We're going to have 3 halves x squared plus 4x. And then why not plus c? Well, for plus c, that's only for an indefinite integral. This is a definite integral. There are bounds to it, so we don't need plus c in this situation here. So we added 1 to the x. It's x squared, divided that, so now it's 3 halves. 4x is raised to the first power, so dividing by 1, you just get 4, so we don't need to indicate that there. So that's our equation. We have to remember our bounds are between 5 and 10. And now we're going to plug this into the equation. So we're going to plug 10 into the equation, subtract it by 5 plugged into the equation, to get our final answer here. So 3 divided by 2 multiplied by x squared, and in this case it's going to be 10 times 10 plus 4 times 10. That gives us a result of 190. And then if we put 5 into the equation, 3 halves times 5 because that's squared, plus 4 times 5, that's going to equal 57.5. So now we subtract these values, and our final answer is 132.5. It looks like answer B is right in that ballpark there. So answer B is the answer to this problem. So how did we solve this? Let's break it down. Area under the curve, we know that means integration. We have the equation here. We identified our bounds, properly integrated the equation, inserted our bounds, and then got the final answer. So that's how to find the area under the curve of a specific equation. If you have any questions about this problem, you should leave it in a comment down below, or let us know what kind of sample problems you would like to see in the future. We thank you so much for watching, and we will see you guys in the next